right. Hello, everyone. My name is Masashi, staff software engineer from Turo payment team. Next to me,
I'm Sig, also a staff engineer at Turo, working with vehicle catalog.
So last year, our dear friend Ayush from API service team at Turo engineering team, he presented here at LeapRide 2023, and his team laid the foundation for us, our domain teams, to start using Temporal. And several domain teams in our Turo engineering started using Temporal, and we are excited here to share our experience and use cases. Yeah, okay. So some of you may ask questions like, what is Turo, what is your business? I'm curious, so how many of you have heard Turo before this session? Wow, a lot of people. So how many of you have used Turo and rent a car? Oh, amazing, I'm happy to see this. Raise your hand. So, okay, for those who doesn't know about Turo, so Turo is the world's largest car sharing marketplace where you can book any car you want, whenever you want, wherever you want it. So our mission is to put the world's 1.5 billion cars to better use, which means you have a car but sitting in the garage and doesn't do anything. Maybe you can rent a car out someone and earn money. And there's a bunch of people who want to use your car when you're sitting in your garage. So we have a vibrant community of guests and hosts. And then our amazing hosts, and we have a host and vehicle can be found in more than 15,000 cities across US, UK, Canada, and Australia and France. And our hosts already earned more than $4.4 billion since our inception. And then we have 365,000 active vehicles, which is lead to his presentation, actually. And another equally important part of our community is the guests. We have 3.5 million active guests, and have driven the 7.8 billion miles since our inception. And we have this net promoter score 77, which is basically the customer experience about Turo. As a reference, Starbucks in Seattle had the same number, 77. So you get the sense of it. Now you know about the Turo, so let's get into the agenda. So Sig going to present his use case, and after that, I'm going to explain my use case, deferred payment.
Thank you, Masashi. So I'm going to talk a little about how we manage our car data at Turo. So at Turo, we're very proud of our extraordinary selection of cars. These are some of the cars you can book on our platform. To power this selection, we need to have a comprehensive list of vehicles and their characteristics. And then we call this collection the vehicle catalog. And it's a collection of something we call vehicle definitions. And we have about 1 million of these definitions globally. Each country has a separate catalog. So for one country, it's typically a couple of 100,000 definitions. And the vehicle catalog powers some key features at Turo. On the car details page, we retrieve attributes about the vehicles from the catalog. It enables you to search for vehicle types, makes, and much more in our search features. And if you're a host looking to list your vehicle, you only have to enter your license plate or VIN number, and then we're able to match that to a vehicle definitions, and we automatically know a lot of attributes about your car. So how do we get this data? We partner with third-party data providers, and it's typically one data provider per country we operate in. And our import process looks something like this. We start by fetching the data set from an external FTP server. And to make things a little simpler, we upload this to an S3 bucket. And then we start importing it to our application database. And we have to apply a lot of rules and logic to convert this data into a Turo format. So for every country, it's a different format, but the output is the same for all countries, a Turo vehicle definition. We also need to fetch valuations. This is something that we run on a more frequent basis as car depreciate. And finally, we make the data available for other services at Turo to consume. So with this use case in mind, how did we get to temporal? So we used to have all kind of batch processing jobs running on Quartz in Java monolith. And a year ago, Ayush Madgal was here to give a presentation about our challenges with Quartz, how we had misfires and scaling problems. And I'm not going to repeat his talk, but it's up on YouTube. So if you're more interested to hear more about how Temporal solved those challenges, you can go watch it. But Turo was going all in on Temporal, and it made sense that we would consider if we could use Temporal for our new jobs that we were developing. So our main challenge was that we wanted to keep vehicle data up to date. It's very important that when a new car is launched and a host go to buy that car and they try to list it at our platform, it's very important that we are able to do so and that we know details about that car. So our requirements was to run the jobs on a monthly basis. And sometimes a job will fail because of unknown data, like the data provider has added a new type. You can think of this as like a new enum value that we map to something internally. We need to add a new mapping. And in those cases, we would like to retry, continue where we left off after deploying a fix. It would also be great if we could monitor the progress, minimize developer time for manual tasks, and for certain tasks, great if we can require human confirmation before continuing with automation. So our architecture looks like this. We have a microservice that we integrate with Temporal Cloud. So all the Temporal workers, workflows, activities are in this microservice along with the rest of the code related to this domain. And we use a MySQL database as storage for this application. And the results, the vehicle definitions are published to a definition queue that the rest of Turo can consume. A typical import workflow is divided into a lot of steps. We want activities to be rather short running. So our import workflow can take a couple of hours to complete in full, but we divide the work up. And it typically starts by fetching what steps it needs to compute, and then we run these steps independently. In most cases, these can be run in parallel. And with Temporal, it's been very easy to set up these kinds of workflow and divide the work in asynchronously. So here is the code to do that. This is Kotlin on line 3, the call to Temporal SDK to run import step asynchronously. And then we wait for the result at the last line. And yeah, we typically do this about different stages in the workflow. And in some other scenarios, we use child workflows. Sometimes we have like a sub-process that is independent and something that you would be able to run on its own. So here we have a parent workflow that's US import, and a child workflow to fetch evaluations, and another child workflow to publish definitions. And if we want to only run the fetch valuations, this child workflow is just like any other workflow. It's only a child workflow if it's spawned within the parent. So it makes it very easy to run it by itself. And when we run into failures, I mentioned that sometimes we need to deploy a fix. We need to add mappings to our internal data format. And we wanted to avoid to be in like a retry loop. These import jobs are heavy on database, and we wanted to also be able to continue where we left off in the workflow when we fix it. So we found this retry interceptor in the temporal Java samples in their GitHub repository. So we just used this pretty much as is, converted it to Kotlin, which is what we use. And it works like it's just returning the result when everything is okay, but when something fails, it ends up in this paused state. And then we send a signal to either retry or fail it. So if we deploy a fix and we want to continue, we send a retry signal. But if we wanted to run the workflow from the beginning, then we would just fail it and start a new one. And we just send this signal from the temporal UI. We have few workflows running, so it's very easy to manage in the UI we get for free as part of the package. And this is how we've set up the schedules. So we use temporal schedules to run these jobs on a monthly basis. We specify a cron statement to specify the interval. So in this example, we have a job that's running first Tuesday of the month. All right, some key takeaways. Waiting for a signal to continue has been a great tool for us to also release new features. So in our import jobs, we do a lot of steps, and it's only the final step that makes the data available for the rest of production systems in Turo. So this is the last step where we could contribute to an incident if we publish incorrect data. So we launched this with a confirmation stage where we have to send a signal to approve the final stage to make it available for the rest of Turo production systems. And this is some step we probably will remove when we are confident about that it works. And but it's good to be able to have that step in so you can do some verifications and query the data before you make it live. A little bit about worker tuning. So our database is the main bottleneck, and some tasks are also heavy on memory usage. So we're limiting the workers to 1 worker per application instance, and we're using shared workers across different workflows. So if you start up multiple workflows, the load is not increasing. They're just going to take longer to complete. And Temporal UI has been really a great tool to give us insight in this progress. If you give them great or good return values from activities and workflows, it's very insightful. And normally you would have to rely on logs for batch processing jobs like this, but here you get a great tool as part of the package. Yeah, so this is how Canada import job looks, the input parameters on top, and yeah, the output of the activities in the bottom. All right, then it's over to Masashi for the next use case.
Well, let's switching the gear to a payment side of a use case. So as I think you are guys engineers, and then you may probably get some Jira ticket or something story. In this case, its story says, as a Turo guest, I want to have a pay later option. at checkout. This is a requirement from product team. How do you design it? So in detail, the product manager mentioned this requirement. So if new car trip reservation, if trip is starting in more than 2 weeks, give the guest 2 options. Says book now, pay later, on top of book now, pay now. 3 days before the scheduled payment, send an upcoming notification to the guest. And on the scheduled payment happens 3 days before trip start. If payment fails with the card on file, notify the guest and then have them fix the card and pay manually. And after the payment failure, 24 hours after the payment failure, we check the invoice status, and if it's still unpaid, unfortunately, we need to cancel the reservation. Also, there's a requirement that we allow the guest to modify and change the date or change the car or trip protection plan. Also, guests can cancel the reservation. So those are detailed requirements. So now we want to show the recorded demo, which I have done in 1 month ago for this conference. So for you to book Turo, just go to the Google and then search Turo. And you go to the home page for Turo, similar to the Airbnb, you put the location and then from when to when. So in my case, 17th of September, put the date and time of rent, or when you want about to rent a car, and then until 20th. But for me, we are in Seattle. How about hit the trail? So I want to extend 1 more day to tomorrow. So you search the car, you find several available cars around the Bellevue here. I pick my favorite car, Porsche, and then check the detail of the car. And important part is to check the host. This host has a 5-star and more than 500 trips. I'm happy with this host and the car. I'm going to the detailed checkout page. There's extra options, but I don't need a booster seat. Just cancel those extras and check the price. Actually, it's more than almost $600 for 4 days. But I have there's a bunch of discount, including my employee credit. So ended up only $200 only. And then here at the bottom, pay now and pay later. This is an option we want to give the guest. So $200 before the trip start, which is September 14th. This is the demo. So this is how, now you know what is the user experiences. Switching to the next one. Okay, so as back-end engineer, we need to design this requirement from product team. So this is a component, system component, a basic architecture. So starting from left to right, front end, web or app request the checkout to reservation service. The reservation service send a request to billing payment service. And if there's a flag for pay later or deferred payment flag, it sends a request to the SKS queue, and that message goes to scheduled payment service, which is a new microservice we developed. That guy interacts with Temporal Cloud through the SDK. And then that message instantiates the workflow execution. And when time has come, the activity is going to be triggered, and then it hit the REST API on either payment or reservation services. If it's payment, it goes to payment provider API. So this sequence diagram, a little bit detail here. So from left to right. So when payment service is asked to schedule the payment, it sends an asynchronous request to schedule the payment service, and also it saves the data about that payment in a local database. And when time has come, there's 3 activities triggered. A similar diagram, but this is a kind of 3 lanes from top to bottom. Top is a reservation service, the middle is a payment billing service, and the bottom is a new workflow service. So top left, there's a WF start, which is when the workflow is instantiated and started. And there's only 3 activities and 3 wait. So the first one is a wait until T minus 3 days, which is T is payment schedule time. And then after the waiting for that until T minus 3 days, it triggers the notification for upcoming charge to the guest through the notification service. Again, we're going to sleep one more time until the payment time, and we're going to trigger another activity which is going to hit the payment service to do the payments. In this case, we are interested in the result of payments. Based on that result, this workflow behaves differently. If it's succeeded, we just end. Otherwise, we wait for another 24 hours and then trigger another activity, which is a check invoice status. When we hit the API to the payments, and in case that payment is not done yet, that event going to be sent to reservation service, and then it may cancel the reservation and send the notification to the guest. So how we implement it? So with Temporal, it's very straightforward and easy. And also, this is our first use case for payments team. So you want to make it simpler workflow. So it starts from step 0 is configuration. We can ignore it. So step 1, notification, as we saw, and then step 2, payment. Step 3, payment fail case. Let's zoom into each step. I just want to show how simple it is. So first one, step 1 is waiting for the notification time. We calculate the time, how much to wait and sleep for that time, and then trigger the notify method of notification activity, which is REST API call to notification service with payment ID. Step 2, and again, it's simple, calculate how much time to wait, and then which triggers the charge activities, make payment method with charge payment ID. And in this case, we are interested in the result from the REST API call to payment service. And based on that result, we're going to go to the step 3. This is, by the way, it's Kotlin. And then basically, if statement based on that result, if it succeeds, it's a happy path, so we just end it, just log it happy. And if it's failed, we wait another 24 hours and then sleep at that time, and then we're going to hit another activity, which is check payment status with the argument of payment ID. So, and then this implementation worked fine. Actually, I cannot tell the exact number, but majority of guests happy to use this use case, and then click the pay later option. And yeah, it's simple workflow, but there's several issues happened in production. First problem, the activity made the API call spikes in production. Early this year, we got some alerts from some workload because any book trip starts at the 0th minute or 30th minute, like 10 a.m. or 10:30 a.m. So that's the scheduled payment time because it's calculated based on that start time. And it created a spike of API calls, and then that affected downstream services. So the solution was jittering. So we don't like that spike because we don't need to make a charge in specific time. So we add that random offset to the payment schedule time and they flatten the spike of API call, and it worked. Another problem we found was outgrowing single namespace. Payments team was the first early adopter for Temporal in our engineering team. We just jumped in the existing namespace for the Temporal Cloud, And then both team, API service team and us, payment team, adding a new feature and new traffic. It ended up, the fourth point actually is APS exceptions, action per second exception, and then we just call the temporal support, and then ask to increase the limit. That's a short-term solution, but basically we are thinking about migrate out from the existing namespace to new cloud namespace. That's what I'm doing right now after I come back to the Bay Area. Lesson learned was namespace segregation. Early name segregation is recommended. Last but not least, this was no problem. I just saw this library in Temporal SDK. I was curious and started using it. It was cool. No problem. Only the happiness here. Basically, this is the cool stuff. Actually, Tiho mentioned yesterday in the workshop. So what you can do is when you instantiate or start workers, first you have to create the service stub, then create the client, then you have to create the worker factory, then workers, and you register the activities and workflow implementation to that workers, right? It's maybe hundreds, maybe dozens of code. With this, you don't need to, that's it. Basically, the last line, package workers auto discovery, that's all you need to do, and some of the annotation in the activity implementation and the workflow implementation. So if you are interested in this library, please check on the Temporal SDK, GitHub. That concludes our sharing of experience of adoption of Temporal. And thank you for listening to our sessions.